Hi everyone. Sorry to miss the class today. So I'm planning to do the lecture online today, so in the form of a video. So what I'm planning to do today is to talk about a little bit more things in section 1.1, 1.2, and if the 15-minute period allows me, we'll go to 1.3. So we started with functions and graphs of functions. So under section 1.1, we still didn't talk about operations with functions, although you've seen those in intermediate algebra. Yeah. So in this section, you are reminded of for operations with functions. So if we start with two functions, f and g, the sum function, yeah, which is notated with f plus g of x. Obviously, I could notate it with h of x, but because we want the notation to be symbolic of the operation we want to do with the functions, we notate the sum function with f plus g of x instead of another function h of x, right? So look at that. This new function, which we notated f plus g of x, is by definition f of x plus g of x, obviously for any x in the common part of the domain of f and g. Well, then we have the difference function, again symbolically notated with f minus g of x. So this new function, which we call the difference, yeah, must be symbolic of the operation we want to do with the functions. So if I notate the difference function f minus g of x, that would be f of x minus g of x. Then we have the product function. As you can see, the notation, the way we notate the product is fg with nothing in between. We know when we see 2x, for example, we write the notation 2x, we understand 2 times x. So the same with this function. When you see fg of x, this means the product function. So all I have to do is to do f of x times g of x. So this is the definition. And then finally, the quotient function is notated with f over g of x. So you divide f by g of x, yeah. So again, this is the notation for this new function, which we call the quotient function. And this f of x over g of x, obviously, provided that the denominator is not 0. So this means g of x is not 0. So basically, x is a value that does not make g of x equal 0. We talked about domains of rational functions last time. So you saw that we always worry about the denominator of a rational function being 0. So we don't want this g of x to be 0. So if that is so, let's work on a problem from your textbook. I'm not going to mention the page because at home I only have an older edition of the textbook. But I'm going to show you. Usually there are the same exact problems. It's just the page is kind of, random a little bit. So here is the problem. We have the graph of a function. Let me zoom in here. Given. So we have two functions. We have f of x is a line and g of x is the parabola, right? And we have some points on the graph of the function. So you're going to see today that we hit a lot on the concept of the value of a function. So we saw in class that the graph of a function is the collection of points x and y, yeah, where y equals f of x, if we are talking about the graph of the function f. So basically, if I have any kind of graph, and I pick a point, so imagine I have y equals f of x. This is the graph of the function. So any point on this graph will have coordinates x, and the y coordinate, how do I come up with the y coordinate? I plug in x in the equation. So the y coordinate is actually f of x. So if this is the point, yeah, m always has coordinate on the graph of f of x. M is a random point. Its coordinates are going to be x and f of x, yeah. So we know this about the graph of a function. So now let's go back to the problem. And the problem is asking me to calculate f plus g of 2. So I'm going to come right here. So I'll have f plus g of 2. So as you can see, this is the sum of f with g at x equals 2. So remember, this is just a notation for some function at 2, the value of the function, the sum function at 2. So by definition, we just said that, this is going to be f of 2 plus g of 2. Yeah. So now I look at the graph, because we have a lot of information from this graph. Remember, f of x is this red line, yeah? So if I want f of 2, this means the y-coordinate of the point of x coordinate 2 on the graph. So I'm looking at the line, and I see, I'm looking for a point of x coordinate 2. So apparently this one, right? So this point has coordinates 2 and f of 2. So the second coordinate, the y-coordinate, is actually the value of this function at 2. So if I want f of 2 from the graph, without even knowing the equation, right? I just look at the coordinates of the points. I calculate f of 2 as being 2. So this is going to be 2. And then g of 2, let's see what g of 2. G of 2 is the parabola. So again, I'm looking at the point of x coordinate 2, and I want to see its y coordinate. So look at that. Its y coordinate is actually this point right here. Am I reading this one wrong? No, this is the one. So look at that. The point right here of coordinate x coordinate 2 has the y coordinate 1. This is 2 and 1, right? So obviously g of 2 will be 1. Yeah, from the graph. Yeah, so this one refers to this point right here, so it's y coordinate that's on the line, and then this one refers to the point of x coordinate on the parabola. So I read the y coordinate. So this is going to be 2 plus 1, which is 3. So we calculate the f plus g of 2 is actually 3. All right, the next question. As you can see, I have the answers here, but this is an instructor's edition, so we do have answers next to the questions most of the time, so I cannot erase those. But just keep in mind, I want to show you how it's done, not what the answer is, yeah? F minus g of 6. So as you can see, I'm doing the difference between the functions. So by definition, this is going to be the first function at 6 minus the second function of 6. Yeah? So let's look at the graph. So what is f of 6 and what is g of 6? So this means the f of 6 means the y-coordinate of the point on the graph that has x-coordinate 6. So I look at the function f of x, that's the line. So I look at the point of x coordinate 6. Looks like it's right here on the x-axis, this one. So what am I interested in if I want f of 6? I'm interested in the y-coordinate of the point, so that will be 0. Okay, I'm making a mess here. So I'm looking at the y-coordinate, yeah? And then minus g of 6, let's see g of 6. So now I'm looking at the parabola, and I want g of 6. So this is the point 6, 1. So x coordinate 6, y coordinate 1. So 1 is actually g of 6. Yeah. So I have 0 minus 1, which is minus 1. I came up with the answer. Let's see. The next one, next question is I want to do fg of 2. Now the book has a dot in here. It's a little dot. It's okay as well, but usually try not to put it. We understand the product between f and g. So by definition, this is going to be f of 2 times g of 2. Yeah. So now let's look at the graph. Remember, f of 2, we already had it before. So this was 2. And g of 2 also, we had it 1. So how do I find out f of 2? I'm looking at the point on the graph of f, so on the line that has x coordinate 2, and I read its y coordinate. So this one, right here. And g of 2, I look at g of x. Look for the point of x coordinate 2, because I want g of 2, and I read its y coordinate, so this is 1. So 2 times 1, this is 2. Alright, let's see some other questions here. How about we want f plus g of 4? Yeah, so the next question is find out f plus g at 4. So again, by definition, this is going to be f of 4 plus g of 4. And now we look at the graph. So f of 4, I look at f of x, which is the function in red, or the line, and I look for the point of x coordinate 4. So you see it right here, x coordinate 4. So now f of 4 is 1. I read its y coordinate. Now if I want g of 4, I look at the parabola, I look for the point of x coordinate 4 on the parabola, and I read its y coordinate minus 3. That will be g of 4, minus 3. So I have 1 plus minus 3, that's minus 2. Okay, the next question is g minus f of 6. As you can see, you can have the functions reverse. Here we had f minus g of 6. Now I have g minus f of 6. So by definition, this is going to be g of 6 minus f of 6. Okay, so I look at the graph. Remember, we already look at those. But again, if I want g of 6, I look at the y coordinate of the point on the graph of g that has x coordinate 6. So g is the blue function. So this is 6, 1. So this is g of 6, 1. And f of 6, I look at the graph of function f of x, and I look for a point on that graph as x coordinate 6, right here. So I read its y coordinate. This is f of 6, 0. Yeah. So obviously when I reverse the difference, right, I want f minus g and then g minus f at the same point, I get opposite answers. Here I got minus 1, and here I got 1. So it makes sense, right? When you change the order of the terms in a difference. And then let's do one more. F over g of 4. F over g of 4. So by definition, right, this is f of 4 over g of 4. So we have to be careful. If g of 4 is equal to 0, then I will be in trouble. I cannot calculate f over g of 4. But let's see from the graph. So what is f of 4? So I'm looking at the line, looking for the point of x coordinate 4. So this is this one right here. I'm reading its y coordinate. Yeah? So x coordinate 4. The y coordinate is going to be f of 4. So this is 1. And g of 4, again, this is minus 3. I'm looking for the point on the graph of g of x coordinate 4. And I read its y coordinate. Minus 1/3. Okay. So that's pretty much it. This is operations with functions. Let's try to do some other applications still in this section. How about, let's see. Let's find out the domain and the range from the graph of a function, yeah? So again, what we are planning to do here is finding the domain and the range from the graph of a function. So let's suppose the graph of the function is given, yeah? So we can do anything from 11 to 22. As you can see, I have a bunch of functions here. So I want to determine the domain and the range for each one of the functions. So let's look at 11, right? So remember that the domain we said, so let's see, what was the domain of a function? So if y equals f of x is a function, the domain we said is the set of all possible values for x that we can plug in to come up with the output, the set of all possible inputs. So by possible means the ones that if I plug them in, I can actually get an output for it, yeah? So let's look at the, the possible inputs x, right? So usually the inputs are, we read them from the x-axis, while the outputs, y, we read them from the y-axis. So let's see. If I look at the graph of the function in problem 11 right here, right? So I want to see for what values of x I get an output. So this means a point on the graph. So you observe that I have here minus 1 and here 1, right? So for example, for x equals 1, I do get an output that is 0. Yeah, the point is on the x-axis. Yeah, and then for example, for any value of x that is greater than 1, right? Like this one, probably 2.5. Let's see. I do get an output, right? I get a point on the graph, so I get an output. So the same for any value that is greater than 1, right? So I pick a value for x greater than 1, and how do I get the output for it? I look for the point corresponding on the graph for that x coordinate, and I read the y coordinate. So basically for any x greater than 1, yeah, I get an output. So any value for x greater than 1, right, where I actually have a graph, if you look vertically of what's happening here, so imagine I have x equals 1 right here. So do you see that from 1 to plus infinity, there is a graph for the function, because the arrows mean that the trend for the graph continues without, interrupting or waving, yeah? So basically this one is increasing, this one the same here, decreasing, yeah, going down. So basically even for an x here, I will have 2 points on the graph, one here and one here. Do you see that? So obviously this is not going to be a function actually, right? Because this is the vertical line test tells you that if I draw a vertical line, for example, through here, I have 2 points of intersection. But we want to find out the domain in the range for the relation, yeah? So maybe we can answer first if this is a function. So this is not a function because of the vertical line test. But let's find out the domain and the range. So as I said, for any x greater than 1, there is a graph. So any x greater than 1 should be in the domain. But then I look on the other side, for any x less than -1, right, on this side, there is a graph. So basically there is a gap in the domain, right? So the domain does not include points in between -1 and 1, like 1/2. Do you see that at x equals 1/2, I have no points on the graph, or x equals -1/2, or x equals 0. So how would I write the domain for this one? So let's write the domain. So for problem 11, we said this is not a function. Then the domain will be, what did we say? We say any numbers between -infinity and -1 together with any numbers between 1 and +infinity. The question is, should I include 1 and -1? Yes, because those are actually this point and this point on the graph. So I should have bracket here, bracket here. And how about the range? Remember, the range will be the set. So the range is the set of all outputs. Yeah, that's what we said, the set of all outputs y. So if I look at this graph, I want to see if I cover all, you know, what values from the y-axis I should exclude. Is there any value that I should exclude? Basically, there is no point on the graph with that particular value of y. So for example, for any point less than -3, like this one, do you see that there are actually 2 points on the graph with that y coordinate? Or for any point great in between -2 and -3, there are 2 points with the y coordinate of that. So I can see that basically I have the entire y-axis covered by the graph. There is a graph left or right of any value of y on the y-axis. So the range will be just -infinity +infinity. There is no gap. Okay, so let's look at problem number 12. Oh, by the way, what are the x-intercepts for this one? The x-intercepts are, look at that, there is one x-intercept is right here, so that's the point -1 and 0, and then there is another point here, 1 and 0. Yeah? All right, so let's see problem number 12. Yeah, problem number 12, I want to see again, is this a function? I would say yes, because according to the vertical line test, every single vertical line I test intersects the graph exactly at one point, so that's okay. Yeah, so it's a function. Okay, now I want to see what's the domain and the range. So the domain, yeah, so I want to see, do I have a graph for any x between -infinity and +infinity, or should I exclude something? As you can see, any point I pick, there is a point on the graph of that x coordinate, right? Look, yeah, any point I pick on the real number line, there is a point of that coordinate on the graph. Look at that, this I have arrow here, so this means the trend of the function, the graph continues that way, and an arrow here. Do you see this weird behavior? It looks like it's getting close to the x-axis but not really crossing it. So here I'll have what we call an asymptote. Yeah, so we say that the x-axis is what we call a horizontal asymptote for the graph. The graph gets closer to it on this side but never really crossing it. So let's see, the domain, I said I will find all kinds of points of any x coordinates. Any x on the x value on the real number line will be a coordinate of a point on the graph, right? So I'll have -infinity +infinity. How about the range? So if I want to write the range here, so look at that. I go from -infinity to +infinity. Look at that. There is no point on the graph that has y coordinate -4 or -100, right? If I go that way. But at the moment I get to 0 or more, right? How about y equals 0? So this means any point with y coordinate 0. Not really, because here I have an asymptote, so this means the graph does not cross the x-axis. But if I go just above 0, like 0.0001, there would be a point somewhere here of that y coordinate, right? So as you can see, I can have y coordinates for points on the graph that go from 0, but not including 0, all the way to plus infinity. So that would be my range. Again, put a parenthesis at 0, because at 0 I have what I call horizontal asymptote. Yeah, horizontal asymptote. So 0 is not included for y as a y value. All right, let's move on. Let's see problem 13. Problem 13. Problem 13, let's see, is this a function? Look at the vertical line test. Yeah, so for example, observe that the graph starts here and ends here. I don't have arrows, so I don't have any graph passing this point on the left or passing this point on the right. So solid dot means the point is included, while other graphs on the book have an empty dot. So solid dot means something similar to what I did in class with the bracket, right? While empty dot means parenthesis, the point is not included. Yeah, like this one. Empty dot versus solid dot. So empty dot means this point is not included in the graph, while the solid dot is. On the board we did bracket versus parenthesis. Alright, so this is a function. Look at that. If I draw a vertical line through here, no intersection points, no intersection points. But if I go through minus pi, yeah, I get exactly 1 point of intersection. If I go to the right of that point, 1 point of intersection every single time, yeah, up to x equals pi. And then no intersection points. So according to the vertical line test, this is a function. So 13, I don't know if you can see this, 13. It's a function. Okay, so let's see domain. For this one, as you can see, I look at the x-axis. There are points on the graph that have x coordinate between minus pi and pi, right? So kind of like this. You see that on the x-axis, the graph goes between minus pi and pi. Yeah, minus pi and pi on the x-axis. So that's going to be the domain, including minus pi and pi. So I have brackets. While the range, yeah, I look at the y-axis. So on the if I look at the y-axis, I only have a graph between minus 1 and 1. Do you see that? Between this minus 1 and 1 only. Yeah. So on the y-axis, I have a graph between minus 1 and 1, and no graph beyond those 2 points. So the range is going to be minus 1 and 1, including those 2. Okay. Let's see. How about 15? So this one right here. So is this a function? Obviously not, because if I draw a vertical line through here, I'll have 2 points of intersection. That's not allowed for the graph of a function. So if I say 15, not a function, just a relation. So how about the domain? So basically I look at the portion of the x-axis where there is a graph. Yeah, that's how I think. Portion of the x-axis where there is a graph. There is no graph between 0 and plus infinity. There is a graph only between minus infinity and 0, because I have arrows here, right? So I have minus infinity all the way to 0, including 0, because I have this point of x coordinate 0 on the graph. And the range, as you can see, will be the portion of y-axis where there is a graph. But there is a graph at minus infinity, because this keeps going like that all the way to plus infinity, right? So the entire y-axis is covered. So this is my range. Okay. Which one do we want to do? How about this one, 17? So let's do 17. So 17 is this one, yeah? Okay, so let's see, is this a function? Yes, it's a function, right? because I draw a vertical line through here, no intersection points with the graph. Here the y-axis seems to be a vertical asymptote, the graph gets close to it but never crossing it, so no intersection points. But as soon as I'm on the right of the y-axis, I'll have exactly one point of intersection every time. Up to this point there is no intersection at this point, x equals 3, and beyond x equals 3 no intersection. Yeah, so either one point of intersection or no points of intersection. So this makes this graph a function. Okay. And let's see, domain and range. Domain is that portion of the x-axis where there is a graph, we said. So look at the x-axis. I have a graph only from 0 to plus infinity. On the left hand side of the y-axis there is nothing, right? So that's 0 to plus infinity, and 0 we excluded because the graph does not really cross the y-axis. Yeah, we have an asymptote here too, so that's why you have to exclude 0. There is no point of y coordinate y equals 0, x equals 0 on the graph. Yeah, for x equals 0 there is no point. Okay, and the range is that portion of the y-axis where there is a graph. Well, let's go from minus infinity to plus infinity and look. So I have a graph starting at minus infinity for y equal, going towards minus infinity, and if I go up, the graph seems to be stopping at y equals 2, isn't it? So I'll have the range minus infinity all the way to 2, not including 2, because this point right here, yeah, it's an empty dot, not a solid dot. So this means the point is not really part of the graph. Any point before that one, yes, but not 3 and 2. 3 and 2 is basically missing. And then I don't have any graph after that. Alright, so this is how we do stuff in terms of reading the graphs. Let's see what else is in here. Let's do another problem from 1.2. So this one says, use the given graph of the function f to answer parts A to O. Okay, so we have a bunch of questions. So the first question is find, let's see if I can get a better view of this one. Again, don't be fooled by the numbers of the problems in textbook. Might be different numbers in your edition, but still you're gonna find this function somewhere, this graph somewhere. So let's see again. You can see the answers here. We want to cover those for a little while. So I want to find out f of 0 and f of 6. So what is f of 0? So I'm looking at the graph of this function f, and at the point of x coordinate 0, it's just that at x equals 0, yeah, I'm going to read the y coordinate of this point. So I got 0 for f of 0, right? How about f of 6? So I'm looking at the graph and looking for the point of x coordinate 6. That's this one, right? I read its y coordinate, so this is also 0, f of 6. Let's move on. How about f of 2 and f of minus 2? Yeah, f of 2 and f of minus 2. So let's look at the graph. So I'm looking for the point that has x coordinate 2, which is this one, and f of minus 2 is going to be its y coordinate. So f of minus 2 is, no, f of 2 is minus 2, yeah? What is f of minus 2 from the graph? So I look for the point of x coordinate minus 2. I read its y coordinate. So this is 1. Yeah. Is f of 3 positive or negative? So I want to see what is f of 3. So this is the y coordinate of the point on the graph of x coordinate 3. Isn't it? I have the point 3 and something, so let's see where that is. So 3 is in between 2 and 4, so I don't have a specific point, but I know that if I draw a vertical line through 3, I get a point on the graph, isn't it? So how do I read its y coordinate? Well, I drop a perpendicular line from the point to the y-axis, and I see what kind of value I have here. That would be f of 3. So is f of 3 positive or negative? So obviously it's below the x-axis, so it's negative. So f of 3 is negative. Yeah. Okay, so this is a negative number. This point right here has y coordinates some negative number because I'm under the origin. Yeah. is f of minus 1 positive or negative? So I want to see f of minus 1. Is that positive or negative? F of minus 1, well, minus 1 is right here. So I have the corresponding point on the graph of x coordinate minus 1 right here. So f of minus 1 is this value, as you can see above the origin. So this is positive. The next question, for what value of x is f of x equals 0? The next question is, for what x we have f of x equals 0. So f of x equals 0 means the y coordinate of a points on the graph have to be 0. So those are points on the x-axis. So I want to see what are the values of x such that f of x equals 0 means I look for the x coordinates of those points that are on the x-axis and also on the graph. So if you look at the definition of a 0 of the function, we said that if I solve the equation f of x equals 0, I find what we call the zeros of the function or the x-intercepts. Those are the points of y coordinate 0. So I can read those values. So I get a value right here. So x equals 0, then x equals 4, and x equals 6. These are also called zeros, yeah, for the function or the x coordinates of the x-intercepts. 1, 2, 3 x-intercepts. Yeah. Next question. For what values of x is f of x less than 0? This is important, yeah, because you have to understand how to solve an inequality like this. So for what values of x is f of x less than 0? Yeah. So what does it mean f of x less than 0? Let's look at the graph. So f of x generally means y less than 0. So I'm looking for all the points, yeah, so the x coordinates I'm looking for, because the question is about x, such that f of x less than 0. So I'm looking for all the points on the graph that have y coordinate less than 0. So generally, if I'm asking you to plot a point in the coordinate plane, rectangular plane, where are you going to have points of y coordinate negative? Somewhere here in quadrant 4 or quadrant 3, isn't it? So basically, points of y coordinate negative on the graph are going to be below the x-axis, isn't it? Yeah. So I'm looking for the portion of the graph. So I'm looking for the portion of the graph below x-axis. Yeah. So I want to see for what x that happens. Yeah. For what values of x that happens. For what are the x coordinates of the points where f of x is negative. So look at that, f of x is negative or y less than 0 wherever the graph is below the x-axis, right? So we observe that that happens for point of x coordinate 0 all the way to x equals 4, right? So all the points right here are going to have y coordinate negative. So look at their x coordinates. The x coordinates are going to be in between 0 and 4. So we answer for what x f of x less than 0? For x such that f of x equals 0. What did we answer? We said for x in the interval or in between 0 and 4. Again, not including 0 and 4 because I want strictly less than 0. So I don't want to include the x-intercepts. For any x in between 0 and 4, I get a point that is below the y-axis. Alright, so we answer this one. This one, right? So x in between 0 and 4. You can write this one as an inequality, 0 less than x less than 4, or x in 0, 4. Alright, so what is the domain of f? This one we answered before, so it's easy to see there is no graph for x less than minus 4 and no graph for x greater than 6. So for what x, that will be the domain. So if I'm asking the domain, that will be all values for x in between minus 4 and 6, where I have a graph. So I have minus 4 all the way to 6. How about the range? Yeah. So do you see that I have a graph between this point minus 2 all the way to the highest point, which is 3. Yeah. So that will be minus 2 to 3. So I'm looking for the portion. Again, this is portion on x-axis where there is a graph. Well, this one is portion on y-axis where there is a graph. Okay, so as we said, there is no graph, so the graph is going to be, in between the highest point on the graph, which is this one right here, of y coordinate 3, and the lowest point on the graph of y coordinate -2. So I say -2 to 3. Always write the smallest value in the interval first. So you go bottom to top. While on the domain you go left to right. So the smallest value is always first in any interval notation. How many times does the line, this is the question in here, how many times does the line y equals -1 intersect the graph? So the line y equals -1, it's a horizontal line. So y equals -1, oops. Y equals -1 is this one right here, -1. This is y equals -1. I'm trying to show you now. My camera is moving. Okay. So how many points of intersection of the graph does that line have? So I have a point here and a point here. So it intersects the graph twice. So this question can be formulated like that. How many solutions we have for the equation f of x equals -1, yeah? The same question. So f of x equals -1 or y equals -1, right? F of x or y means the same thing. So this means the same question as this one. So how many intersection points do I have? I have 2 of them. So if I say how many solutions do we have for the equation? 2 of them. There is an x corresponding to y equals -1 here. I don't know what that is. And another one here. Yeah, I don't know what that is. I cannot read them exactly, but I can see that I have 2 solutions. And okay, so we talked about that. Let's see another one. Let's see problem 26. So problem 26 is asking, let's see problem 26. Here is a function. Is the point 1/3 on the graph of f? How do I check that one? So in order to check whether a point is on the graph of the function or not, you want to see if I plug in x equals 1 in the equation, do I get 3/5? So basically I want to check, check if f of 1 equals 3/5. Yeah, that's what it means, because I said this is always, if the point is on the graph, this is f of 1. 3/5 is f of 1. So let's calculate f of 1 here. F of 1, this is your equation. So that will be 1 squared plus 2 over 1 plus 4. So this is 3 over 5. So what do we say? Because f of 1 is 3/5, this means the point 1 and 3/5 is on the graph. Yeah. Alright, so we answered this question. If x equals 0, what is f of x? So question in B basically is asking to plug in x equals 0 in the equations. So f of 0, that will be 2 over 4, right? 0 plus 2, 0 plus 4, so that's 1/2. We answered this one. What is the point on the graph corresponding to x equals 0? So if f of 0 equals 1/2, this means I have the point 0 and 1/2 on the graph. Remember we said that any point on the graph has coordinates x and f of x. In our case, it's 0 and f of 0, but f of 0 is calculated. Yeah. Let's see. If f of x equals 1/2, what is x? What points are or is r on the graph of f? So if f of x equals 1/2, so let's see how do we handle this one. So this one is asking if f of x equals 1/2, what is x? So this means I need to solve this one for x. F of x equals 1/2. Well, f of x is this one, so I have x squared plus 2 over x plus 4 equals 1/2. Yeah? So do you remember how to solve an equation involving rational equation? This is actually a proportion. So either I multiply both sides by the common denominator, or in this simpler case, yeah, because this is a proportion, we can cross multiply. We learned that from algebra for proportions, yeah. So I have either I multiply by the LCD, which is 2 times x plus 4 both sides. This is the LCD, or I cross multiply. It's exactly the same thing. Yeah. Or cross multiply. Okay. So just gonna get rid of the book for a second so you can see this. So let's solve this equation. So I'll have 2, if I cross multiply, 2 times x squared plus 2 equals 1 times x plus 4. It's easiest like this. Yeah. So distribute 2x squared plus 4 equals x plus 4. You notice that 4 and 4 on this side, they cancel out. So I have 2x squared minus x equals 0. So here, you try to factor out. It's a quadratic equation in a simpler form. So I factor out an x. So I get 2x minus 1 equals 0. So now according to the zero factor property, I have either x equals 0 or 2x minus 1 equals 0, which means x equals 1/2. Yeah? So we got the solutions for this one. So the question was, for what x, f of x equals 1/2. So we find out for x equals 0 and x equals 1/2, we got f of x equals 1/2 as well. Yeah? So this means that f of 0 equals 1/2 and f of 1/2 equals 1/2. Yeah? So what points are those on the graph? Those are points 0 and 1/2 and 1/2 and 1/2. Yeah? So these 2 points, this and this. What is the domain of f? Yeah, so we want to find out the domain of the function f of x equals x squared plus 2 over x plus 4. Remember we did this type of problem last time? So we are worried for this type of rational function about the denominator being 0. So the only value that I cannot plug in will be the value that makes the denominator 0. So if I calculate this one separately, I want to see when the denominator is 0. I can see that the denominator is 0 for x equals minus 4. So the domain, yeah, will be all real numbers except this value that makes the denominator 0. So this will be all reals except x equals minus 4. This is the domain. Okay. List the x-intercepts, if any, on the graph of f. So again, we are supposed to find out the x-intercepts. So obviously for this function, the function was x squared plus 2 over x plus 4. So if I want the x-intercept, this means I plug in y equals 0 in here. So either y or f of x means the same thing, yeah? So I need to solve y equals 0, right? I plug it 0 in here for y. So 0 equals x squared plus 2 over x plus 4. So this is what I want to solve for the x-intercepts. So a fraction is equal to 0 when its numerator equals 0, right? Numerator of this fraction must be 0. Any fraction that you know that is equal to 0 must have the numerator 0. Yeah. So I'll have x squared plus 2 equals 0. Numerator must be 0. But notice that x squared equals minus 2 does not have real number solutions, because this is positive all the time, this is negative, positive equals negative. That's a false statement, so no real solutions. Yeah. So if I couldn't get any solutions for plugging in y equals 0, we couldn't solve for x, so I say no x-intercepts. Yeah. List the y-intercept if there is one. of the graph of f. So let's find out the y-intercept. Yeah. So the y-intercept, we plug in 0 for x. So basically I want to calculate f of 0, which is 0 squared plus 2 over 0 plus 4. So that's 2 over 4, which is 1/2. So what point is this one on the graph? Is the point of coordinate 0 and 1/2. That's the y-intercept. What are the zeros? The next question is, what are list the zeros of f of x. So remember that in order to find out the zeros of a function, I have to solve the equation f of x equals 0. The solutions of this equation are going to be the zeros of the function, but we tried that before. So f of x is x squared plus 2 over x plus 4 equals 0. I want to solve this one. A fraction is equal to 0 when the numerator is equal to 0. So I have x squared plus 2 equals 0. But this one doesn't have real solutions. We just explained that before, right? Positive equals negative. No real solutions. So I have no zeros for this function. So basically no x-intercepts means no zeros either, right? That's kind of the same thing. Alright, so that's that. Let's see what else we can do. Let's move on to let's see what we can do here. I talked about 1.2. Let's do a few more, or maybe one more. This is in section 1.1. So here it is. Let's do 85. Yeah. 85 says if f of x equals, can you see this one? Let's see if we can see this one. 85. So if f of x equals 3x plus 8 over 2x minus a, where a is a constant, and f of 0 equals 2, what is the value of the constant a? So I'm just going to use the condition f of 0 equals 2. So let's see what that means. Well, f of 0 means I look at the function and I plug in x equals 0. So this means 3 times 0 plus 8 over 2 times 0 plus a must be equal to 2. That's what this condition says. So as you can see now, this is just an equation in which the only unknown is the constant a. So let's just find the constant a. So I'll have 3 times 0, 0 plus 8. So 8 over 0 plus 8, that's a equals 2. Yeah. So if you cross multiply, this is also proportion. So I have 2a, right, equals 8. So I multiply 2 times a equals must be equal to 8 times 1. So 2a equals 8. So a equals 4. We found it. Yeah. So you have this type of problems in there as well. Alright, so we'll talk about the graph of a function. I did some application. Let's move on to properties of functions. I still have some time. I plan to do a 15 minutes kind of video. So let's talk about properties of functions. You do have the lecture notes posted in iCampus, so I'm just gonna use those and talk about stuff right here. So properties of functions. I have this one from section 1.2. So we talked about vertical line test in 1.2, zeros of a function, information from the graph, yeah, solving inequalities and equations connection with the graph. Remember, we solve those inequality. Find out all x for which f of x is less than 0. So this means that the graph of the function, or the y coordinates of the points on the graph, are negative, means the graph of the function is below the x-axis. If I want to solve f of x greater than 0, right, I'm looking for the points where the graph is above the x-axis, because y is positive. Yeah. So maybe you want to put those in there. So for what x, the graph of f of x is below x-axis. That's what it means to solve f of x less than 0. While here, if I want to solve f of x greater than 0, this means I'm looking for what x? The graph of f of x is above x-axis. We're going to come back to this interpretation over and over again for all the functions we are going to study in this class. So it's very important you remember what this means in terms of the graph. Yeah. So if I'm trying to solve the inequality f of x less than 0, means I'm looking for values of x, of the points on the graph, right? So for what x, the graph is below the x-axis. Well, this one, the graph, I'm looking for x where the graph is above the x-axis. So those are the key words, below x-axis and above x-axis. Okay. So let's see, today properties of functions. So first of all, we are going to start with an even, with properties of a function being even or odd. So those are called the even-odd properties. So imagine that f is a function and x is an input for the function in the domain. Yeah. So we say that here are the definitions. A function is even. This is the definition. So maybe I should emphasize this one. This is definition. You need to memorize the definition. Yeah. A function is even if f of minus x, so this means I plug in minus x instead of x, is equal to f of x. So basically, think about it. If I replace x with minus x and the value of the function, the y remains the same, this means that I'll have actually a symmetry of the graph with respect to y-axis. Yeah. So we have an even function has the graph symmetrical with respect to the y-axis. Yeah. So this is the first observation. Because I'm replacing x with minus x and nothing changes in the expression of my function. That was the test for symmetry with respect to the y-axis. And again, the definition of what does it mean for a function to be odd. We say a function is odd if f of minus x is minus f of x. So look at what happens when I replace x with minus x in the equation. I get the opposite y. Yeah. So what does that mean in terms of the graph? So this means that the graph has symmetry with respect to the origin, right? So I replace x with minus x. I don't get a point in quadrant 2. I get a point in quadrant 3, right? So that's the even-odd properties. So this is the observation. So if an odd function has the graph symmetrical with respect to the origin, it means it's odd. So let's test that for some functions. I'm going to show you how to do them, and then I think I'm going to stop. So let's pick an example here. Okay, so let's see. Imagine that I have this equation, f of x. So let's see. F of x equals, let's try x to the power of 4 plus 3 over x to the power of 2 minus 1. The question is even or odd? That's the question, yeah? So let's test. How about even? So remember what the definition says? The definition says that if I manage to prove that f of minus x equals f of x for any x, then the function is even. So this is what I want to prove. I want to see if it's true. F of minus x equals f of x. Let's try that. So let's calculate separately f of minus x and f of x and then compare them. So f of minus x will be minus x to the power of 4 plus 3 over minus x to the power of 2 minus 1. So this is going to be x to the power of 4 plus 3, right? Because minus x to the an even power is x to the power of 4 over minus x to the even power 2, again x squared minus 1. Yeah? Well, f of x, we already have it, so we don't have to calculate anything. I'm just writing it here for the comparison purposes. So I'm looking at f of minus x and f of x. How are they? The same or different? Just compare. So obviously they are the same. So we just prove that in general f of minus x equals f of x for any x. Why do I say for any x? Because I didn't try f of minus 3 equals f of 3. Yeah, like for a specific value. I'm working with a general value of the input x. Yeah. So what do I say if f of minus x equals f of x for any x? The function is even. So I have yes for the question. Let's see if the function is odd. So the question is this function odd? Yeah. So remember the definition for an odd function. We said that if we manage to prove that f of minus x is minus f of x, so basically the minus goes in front, yeah, for any x, this function is odd. So that's the question that we want to answer. Yeah. So again, I start with the left hand side, so I want to calculate f of minus x, and then on the right hand side I want to look at minus f of x and then compare. Yeah, just like before. I'm comparing left hand side with the right hand side. So f of minus x, I look at the expression. This means that wherever I see input x, I put instead minus x. So I have minus x to the power of 4 plus 3. We already did that. Minus x to the power of 2 minus 1. So this is x to the power of 4 plus 3 over x squared plus minus 1. Yeah, so this is what we got for f of minus x. Now what does it mean minus f of x? This means that I'm just adding minus in front of the function right here. So I'll have minus fraction line x to the power of 4 plus 3 over x squared minus 1. There is not anything else that I can do. So now I'm comparing equal or different. As you can see, this one has an extra minus in here. So I say that f of minus x is not equal minus f of x. So this means f is not odd. Okay, so it's a no to this question. Okay, so this is how I test for even odd properties. So let's just look at some questions here, and you tell me whether the graphs or whether these functions are even or odd. So let's start with let's say this one. What do you think, even or odd? I said the function even, that is even, has the graph symmetrical with respect to the y-axis. Is it true? Yes. If you imagine folding the graph along this y-axis, you can see that this part of the graph will completely overlap this part. This is also even, right? It has symmetry with respect to the y-axis. How about this one? Well, can we test to see if this is even or odd? Even means symmetrical with respect to the y-axis. Is that true? If I fold the graph along the y-axis, you can see that this part is going to overlap something here, not on the graph, yeah? So this function is not even. Let's try the to see if this is odd. So we said that the graph of a function that is odd has symmetry with respect to the y, to the origin. Is that what I said? Yeah, with respect to the origin. So basically any point in quadrant 1, if I connect to the origin and continue with the line segment that is equal to this one, right, will get me to another point on the same graph. Do you see that's true? So when I replace x with minus x, I'll get the opposite y. That's what it means. So for example, pi over 2 is replaced with minus pi over 2. Instead of getting 1, I get minus 1. Yeah. So this goes for all the points on the graph. You can see that I have that type of symmetry. Yeah. So this is an odd function because it has symmetry with respect to the origin. How about this one? Has symmetry with respect to the y-axis. So this function is even. Yeah. Alright, so I'm gonna stop here. We'll do some more properties in class next time. But I did start on section 1.3, so we talked about even and odd properties. Bye.